So today I'm going to do equation of a plane passing through three non-collinear points. Now suppose we have 3 points A, B, C which are non-collinear, and the point lies like this. So here we have X, Y, Z axis, and here we have a point A whose position vector is small a vector. Then we have a point B, and here you have a point C. So we need to find the equation of the plane passing through these 3 points. So before, since we are doing vectors, 3D geometry which is an extension of vectors, so what we're going to do is we need to find the position vector of these 3 points. So this is one of them, this is the another one, and this is what we have. But in order to find any equation of any given curve, any line, anything, there must be a general point. So here also we'll be taking a general point, and that point will be defined by P. We're going to write that to be a point P, and for this point also there will be a position vector. So like this way we're going to draw the position vector of that point P. So now what we're going to do is, in order to find the equation, we're going to join this line AP. This line we're going to join, one second, yeah. So this line, this vector we have, so vector joining the 2 points A and P. So this P vector is what? It is R vector, and this A vector is the position vector of A is A vector. So AP vector will be given by position vector of P minus position vector of A. So it becomes R minus A. So this is the position, the vector AP joining the points A and B. That's, we know that terminal minus initial, that's how we find any vectors. Now once we do that thing, what we see is that the AP vector lies on the plane, right? Now whenever we have done any equation of a plane, we always had a vector on the plane and a vector perpendicular to the plane. So then we can do the dot product of them and we can write equal to 0. So we get the equation of the plane. So in this case also we already got a vector on the plane. Now we need to get a vector which is perpendicular to the plane. So for that, what I'm going to do is, the remaining 2 points I will join these 2 points A and B. So you'll get an AB vector. Then I will join A and C. You will get an AC vector. So both of these vectors AB and AC, they also lie on the same plane. The point B has a position vector of small b, and point C has a position vector of small c. So the 2 vectors which we found is AB vector, and AB vector will be given by position vector of B minus position vector of A, terminal minus initial. So it gets B minus A, and AC vector is given by C minus A. So this is what we get, the 3 vectors which are on the plane. So in order to get the perpendicular vector, so what we're going to do is we're going to use these 2 equations, these 2 vectors, and we'll do cross product of them, because we know that thing, cross product gives you a vector. If you do a cross product of 2 vectors, then it gives you a vector which is perpendicular to the plane in which the 2 vectors lies. So suppose we have A vector in here and we have another B vector in here, and if you're going to do cross product of these 2, so from A to B, so what happens is that A cross B is given by a vector A cross B which is perpendicular to both of them, and that's the direction of the unit vector of A cross B. It is perpendicular to the plane in which A and B lies. So if I do AB cross AC, so what I'm going to get is I will get a vector which is perpendicular to both the vectors. It means, and both the vectors lie on the same plane, that is the plane whose equations we need to find. So if it is perpendicular to the to both the vectors AB and AC, so obviously it is perpendicular to the plane also. And if it is perpendicular to plane, the thing which we are asking to find was a vector which is perpendicular to the plane. So we get the normal of the normal to the plane, and then we already have that AP vector. So if you do the dot product of AP vector and that cross product of AB and AC, that will be equal to 0, because AP will also be perpendicular to AB cross AC. So I'm going to write here AP is perpendicular to AB cross AC, which we already seen. So since they are perpendicular, we know that when two vectors are perpendicular, their dot product is equal to 0. So we're going to write AB cross AC equal to 0. So this is how we will get the vector equation of the plane. So AP vector, you just write the values of AP vector. So that is R minus A, which we already found out, and AB vector, the value is, one second, it is B minus A, and then AC vector is C minus A. So by writing like this, we get the equation, vector equation of the plane. So this is known as the vector equation of the plane. So that's how we find vector equation of the plane. Now for Cartesian equation of the plane, what we're going to do is, for Cartesian equation of the plane, we already know the coordinates. We know the coordinates of A is x1, y1, z1. The coordinate of B is x2, y2, z2. Coordinate of C is x3, y3, z3. And coordinate of P is, we know that that's a general point, so it will be x, y, z. So we have to find what? We need to find R minus A. So R minus A is nothing but, it will be given by x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap. So this is how we get R minus A. Now you need to get B minus A. So B minus A comes out to be the coordinate of that point B is x2, y2, z2. So it comes out to be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap, and this will be C minus A. This comes out to be, the coordinate of the point C is x3, y3, z3. So it comes x3 minus x1 I cap plus y3 minus y1 j cap plus z3 minus z1 k cap. Now since we are doing cross product, and we know one thing, whenever we do cross product of two vectors, it can be represented by the help of determinants. So the cross product of B minus A and C minus A can be given by like this. So it will be I, J, K. Since we have that B minus A vector first, so in the second row we're going to write x2 minus x1, y2 minus y1, z2 minus z1, and here it will be x3 minus x1, y3 minus y1, and z3 minus z1. So this is what we get. Now in order to find the equation of the plane, Cartesian equation of the plane, so we need to do the dot product with R minus A. So R minus A we already have. This is what we get, R minus A. So this vector dot this one, R minus A dot this thing, right? So this dot this will become what? You see I dot I, it becomes 1. So basically in place of I in here, I'm going to write x minus 1, and then y minus y1, j dot j is 1. So in place of j I will write y minus y1, and then k dot k is 1. So in place of k cap I'm going to write z minus z1. So the thing which we need to find is, we need to find R minus A dot B minus A cross C minus A. So in place of this entire thing, what we are remaining with, since we are doing the dot product, we can write x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, and that is equal to 0. So this expression in here is nothing but your Cartesian equation of the plane. So here this one, this is equal to 0, is the Cartesian equation of the plane.